A quote from Michio Kaku: Einstein said that the universe is a kind of bubble that is expanding. However, string theory says that there are other bubbles out there, a whole foam bath of universes. And if string theory is correct and such a multiverse exists, we can also say what happened before the Big Bang. The Big Bang was a collision or splitting of universes. So could it be that the Big Bang wasn't the beginning of everything after all? That the creation of our universe was just one of countless Big Bangs, and that new universes are still being born out there today? Well, this exciting theory is not only supported by Michio Kaku. It has now been given a new impetus by a surprising discovery made by the James Webb Telescope. A team of experts has recently come to the groundbreaking conclusion that our cosmos was created in the first place by merging with another world. So, be sure to stay tuned until the end to find out all the details of this exciting Webb discovery. Some simple questions require incredibly complicated answers. The question of what happened before the Big Bang and whether there was even a before is still hotly debated among experts today. However, Stephen Hawking took a very clear stance on this issue, stating, "The question of what was before the Big Bang is just as meaningless as asking what is north of the North Pole because time itself only began with the Big Bang. This is an event that cannot have been caused by anything or anyone. The laws of nature themselves tell us that the universe could have come into being without any energy or cause." In summary, according to Hawking, the answer to the question of what came before the Big Bang is simply nothing. But as you heard at the beginning, there are experts who have their problems with this assumption and who refer to the wondrous world of string theory. Basically, this theoretical concept attempts to describe the fundamental building blocks of the cosmos in a new way. Instead of viewing particles such as electrons or quarks as point-like objects, string theory considers them to be tiny one-dimensional strings or threads located inside each particle. And in the context of a possible multiverse, the theory offers some conclusions that put our imagination to the test. For example, that every world that is conceivable also exists. In other words, life is only developed in our universe because, among all the countless universes, there must be one in which the physical laws are so perfectly intertwined. On the trail of the Big Bang, regardless of whether there's ultimately only one all-encompassing cosmos or an infinite collection of universes, the established assumption still holds that the universe came into being around 13.8 billion years ago in the Big Bang. But how can we know that today? Well, to understand this, we have to go back to the 1920s and dive straight into what was probably the most significant astronomical upheaval of all time. Thanks to researchers such as Edwin Hubble, experts realized for the first time that the Milky Way is by no means the only galaxy in the universe and that most distant galaxies are actually moving away from us. The cosmological worldview of a rigid, unchanging universe collapsed practically overnight. And so it became clear that it wasn't actually the galaxies that were moving away, but rather space itself that was continuously expanding. Once researchers had recognized the expansion of the cosmos, they were able to reverse its development and calculate their way back to its beginning. More precisely, this refers to the point at which the density of matter and energy became infinite and all spatial distances became zero. This original singularity thus marked the extreme starting point from which matter, space, and time emerged billions of years ago. However, things become even more mysterious when we consider what happened immediately after the Big Bang. According to the standard model of cosmology, there was an almost ridiculously short phase in which the universe expanded at an absurdly fast rate. Specifically, scientists assume that during this cosmological inflation, the cosmos expanded by a factor of 10 to the power of 30 to 10 to the power of 100, and that in a span of time that makes a blink of an eye seem like an eternity. But the universe would not be the universe if it had already revealed all its secrets to us. The bottom line is that we are still a long way from deciphering the ludicrous growth spurt of the newly born universe. On the contrary, cosmological inflation still represents one of the greatest mysteries in research, and some experts even doubt that it ever took place at all. However, those experts who do not share this view suspect that there was always a special field that has had a significant influence on the uninhibited expansion of the universe, the so-called inflaton field. Depending on its state, this causes the cosmos to expand, stagnate, or expand at unimaginable speeds. And assuming that the inflaton field was in a false vacuum shortly after the Big Bang, random quantum fluctuations, or in other words, tiny random fluctuations in the values of the elementary particle fields, could have caused it to change into a true vacuum or into another false vacuum with lower energy. To clarify, in this context, a real vacuum refers to an area with minimal energy, which does not necessarily have to be zero. In fact, a real vacuum can very well contain mass and energy. There just cannot be a state in which this area contains even less energy, because then it would be a false vacuum. Consequently, it was the state change of the inflaton field that set the inflation of the cosmos in motion. However, during its transition from one vacuum state to another, the field also released energy in the form of radiation and matter, thus literally creating its own break block that ended the inflationary expansion phase. However, the whole truth is that this widely held assumption is not universally accepted. Researchers such as American physicists Paul Stenhardt and Alexander Vilenkin proposed as early as the 1980s that cosmological inflation did not ultimately come to a complete halt. Applied to a higher context, this means nothing other than that new universes are constantly being created out there. In short, random quantum fluctuations could also form individual bubbles in which the inflaton field takes on just the right value to end inflation. Elsewhere, however, and this is the exciting part, this process would continue unhindered. The result would be that what we commonly refer to as a universe would merely represent a bubble-shaped section in which our world is unfolded. And if this really is the case, then there must also be other bubbles in which other universes have formed. Against this backdrop, the Big Bang would no longer have been the beginning of literally everything, but only the beginning of the end of the inflation in our bubble. The bottom line is that in this model, there is no such thing as a beginning of everything, only eternal inflation from which new universe bubbles are constantly splitting off. But is there any solid evidence for this theory? Which is probably the crucial question. Well, possibly. But first things first, to understand what this means, we need to briefly recall that in practice, the universe does not always do what it should in theory. More specifically, this refers to the mystery of the Hubble constant, which indicates the speed at which the cosmos is currently expanding. On paper, the corresponding value is 67 kilometers per second per megaparsec. But real observations in space using supernovae, red giants, gravitational lenses, and variable stars reveal a dramatically higher expansion rate. This means that the Hubble constant is suddenly 73 kilometers per second per megaparsec, and the James Webb Telescope has recently confirmed this confusing discrepancy in a new study. Why our theoretical predictions differ so greatly from cosmic reality is an open mystery, but the study published by Jan Amburn and Yoshiyuki Watabiki in the Journal of Cosmology and Astroparticle Physics provides an astonishing answer. In fact, the accelerated expansion of the universe could result from the constant merging with other universes. What's more, according to the experts, the merger with so-called baby universes can even explain the collected data better than the standard model. Specifically, the researchers demonstrated in their study that the merger with other worlds should increase the volume of our own. Our measuring instruments would in turn perceive this circumstance as cosmic expansion. In addition, the researchers also determined the expansion rate that would occur in such a case and found that their values corresponded better with actual observations in space than predictions of the standard model. Furthermore, Amburn and Watabiki also addressed the problem of cosmological inflation and unceremoniously threw the inflaton field overboard. Instead, the exponential growth spurt could also be explained by the fact that our young universe was absorbed by a larger mother universe at that time. We would then have done the same as our cosmic mother and also started to collide with other baby universes and swallow them up. But does this solve the mystery of the beginning of our cosmos once and for all? Is it time to finally shove a Big Bang? Well, not quite. Even if, and that's a big if, the new theory matches reality, it would only push the chain of questions further back. For how did the corresponding mother universe come into being? What came before? And was there even a before? As we can see, the cosmos never tires of presenting us with new mysteries, no matter how exciting the theories we come up with to try to figure it out. And if you want to stay up to date with our videos in the future, you can now simply click on the subscribe button. We'd love to have you as part of our community so you can stay up to date from now on. We'll see you soon.